You know, in the bright, shiny world of artificial intelligence, there's a kind of shadow war being fought. It's not over computer chips or code, but over the mind of AI itself. And right at the center of it all is this incredible, almost magical technique, a kind of digital alchemy that can make AI smaller and faster, but can also be used to, well, steal its secrets. Let's figure out how they do it.
Look at this. This isn't from some sci-fi movie. It's a real statement from the AI company Anthropic. I mean, listen to those words. Industrial-scale campaigns. Illicitly extract capabilities. This is a company describing a brand new kind of high-tech spy game. The stakes are just massive. We're talking billions of dollars in R&D, and it all comes down to one really fascinating question.
Right? When a company like Anthropic says someone is extracting capabilities, what does that even mean? How on earth do you look inside a competitor's AI, which is basically a black box, and just pull out its secrets to build your own? Well, to understand the heist, we've got to start by looking at the crime scene.
And let's be clear, this is not some lone hacker in a dark room. The attacks that Anthropic found were on a scale that just completely changes what we think of as corporate spying. The sheer volume is just wow. Anthropic spotted over 16 million exchanges with their model, Claude. An exchange is just a single prompt and a response, one little conversation. But these weren't people asking for poems. This was a systematic, relentless effort to figure out exactly what Claude was good at.
And get this wasn't the work of just a handful of people. To pull this off and try to stay hidden, the attackers used around 24,000 fake accounts. That just screams a highly coordinated, well-funded operation designed to look like background noise.
So how did they know it wasn't just a bunch of superfans? Well, this slide shows the digital fingerprints they left behind. You had this coordinated traffic coming from what Anthropic calls Hydra clusters. It's a great name, right? Think of a mythical beast with many heads, one central brain controlling a huge network of fake accounts to just hammer the system. The prompts were super repetitive, all laser-focused on pulling out very specific, valuable skills, like coding or complex reasoning. It was a targeted smash and grab, not just casual use.
Okay, so we've seen the scale of the crime. But what's the actual technique? What's the alchemist's formula they're using to turn one AI's intelligence into another?
The secret sauce is something called knowledge distillation. And here's the twist. It's not some evil secret technique. Actually, it's a super common and totally legitimate way to train AI that's been around for years. The idea is pretty simple, really. You use a giant, powerful, and very expensive teacher model to teach a smaller, much cheaper student model.
And this comparison just nails it. Think of the big teacher model like a master's grimoire, a huge ancient book of spells that took forever and a ton of resources to create. The student model is like the apprentice's scroll. It's a compact, fast, and cheap-to-use copy. This is exactly how we get powerful AI to run on our phones without needing a supercomputer in our pocket.
Okay, and this is the really crucial part. Distillation isn't just the student model cheating on a test by copying the final answers. It's way, way deeper than that. The student is actually trained to mimic the teacher's thought process, the probabilities it assigns to all the possible answers. It's learning why the teacher thought answer A was the best, but also why B was a close second and C was totally wrong. It's not just copying the result, it's learning the reasoning behind it.
Now, it turns out this whole knowledge transfer thing isn't a one-size-fits-all deal. The research shows there are actually 3 different paths an alchemist, or a thief, can take to pull out a model's essence. So you've got these 3 main approaches. Response-based, which is all about the teacher's final output. Then there's feature-based, which kind of peeks inside of the teacher's inner workings. And finally, relation-based, which tries to learn the web of connections the teacher makes between different ideas. Okay, let's break that down real quick. The classic way is response-based, where you're copying those soft predictions we talked about. With feature-based, it's kind of like the student is getting the teacher's lecture notes. It's learning from the step-by-step process the teacher uses internally. And then you've got relation-based, which is the most abstract. Here, the student learns the relationships between concepts in the teacher's mind. It's less about the what and more about the how it all fits together. So, we have this unbelievably powerful and flexible technique. And this brings us right to the heart of the whole story. Is knowledge distillation a tool for making things better, or is it a weapon for stealing secrets? On the one hand, you have the benevolent alchemist. And look, this technique is a massive force for good. It makes powerful AI accessible to startups and researchers who could never afford to build a giant model from the ground up.
It lets AI run on our phones. It basically helps democratize artificial intelligence.
But, and this is a huge but, you also have the rogue sorcerer. The risks here are just as big. We're talking about intellectual property theft on an industrial scale. And what's worse, when these AI abilities are stolen, they're ripped out without any of the safety features the original creators built in. This means really dangerous capabilities could spread like wildfire, completely bypassing any security or government controls.
And hey, this isn't just some vague theoretical problem. Anthropic puts it in really stark terms with this quote. This is the absolute nightmare scenario. Stolen AI, stripped of its safety guardrails, being plugged directly into military, intelligence, or surveillance systems. All of a sudden, this isn't just a business problem, it's a global security threat.
So, where did that leave us? We're looking at a piece of technology that is absolutely central to the future of AI, but it's one that carries both incredible promise and just immense risk.
And really, this sums up the whole paradox perfectly. The very same technique that can bring AI to everyone by making it small and efficient is the exact same one that can be used for corporate espionage on a scale we've never seen before. It's a classic double-edged sword, and the entire AI industry is trying to figure out which edge is going to cut deeper.
Because at the end of the day, this alchemy is permanent. Once that knowledge is distilled, once the essence is out, you can't put it back in the bottle. And that leaves us with this huge, profound question for the future. Is this the key to unlocking AI for everyone? Or have we just opened a Pandora's box that's going to kick off a whole new era of conflict? The answer? Well, it's still being written.